So next is uh, testing using the simulation. So as a mechanical student, we have seen many simulations can be used for thermal analysis, for impact test, and for vibration test. Mainly, ANSYS is preferred in college and the institution level or organization. So here is one more tool which we can use for simulation of battery model for vibration test and all. So here we have created one battery model which will drag here. So while doing a model survey, we have to design our one model which we are going to use in the battery pack. For example, even if it is a prismatic type or it is a, cylindrical type. So we have designed our own cell, which is prismatic cell placed in a single casing. So initially, we can choose the different material and the cell chemistry, so what type of cell we are going to use, and we are going to see the shaking of the cell or the casing and where the major impact will come. So here you can see the complete battery pack is placed inside the individual casing. So the material is aluminum for the casing. So mainly in two-wheeler, we use MS material, but for car batteries and forklift, we preferred aluminum for better. So now we have to fix 2 points of battery casing. For example, we are fixing these holder points here. It will be fixed, and then we have to run the simulation. But before that, we have to give some directions and the frequency. So here are the desired frequency we can give at which our battery will be shake and will get the vibration rate. So here you can see the number of frequencies we can use, or manually we can put it. So these are the ideal values we have put on in. So to get the vibration test. So we have given the fixed supports at the two end of the batteries. And for the excitations, we have to select one phase, either it is a bottom, because we have fixed the top end. So we'll select the bottom end and with the frequency and acceleration rate. So at this acceleration rate, we can get the testing done. So we can increase it, we can reduce it as per our requirement directly. So ideally, we preferred these values for step by step testing. So while base would be the bottom side for the acceleration, and now we'll select the direction in which our vibration will conduct. Either it is in horizontal direction, vertical direction, so that the battery pack will keep vibrating for some period of time, which will give us the which one is the weakest part of the casing. Now we have chosen the horizontal axis. So this is the complete mesh here you can see, and after running simulation, we have got few results as you can see in the slide. So this is our complete mesh design. So we have taken a frequency as a 200 hertz, and now we are running the test for the prismatic cell. These are the aluminum casing we are used. We can use a different type of material even in metal. So here you can see the displacement is 7.8, which we have ideally kept. We can increase it later on. So now with the frequency of 200 Ah, and the battery pack is shaking, and which will give us the result which part is kind of getting high trace and getting heated, not heated, the high stress where the failure can be happen. So this is the simulation we preferred before going for the mass production. So we'll see the stress now after doing the simulation for some time. So here you can see we had a fixed 2 points, and now the maximum stress is taken at these points. So here you can see the different types of color is showing it. The stress is increasing as per the fixture is given at the left and right corner side of the casing. So ideally, these types of tools are majorly used to determine the strength of a sail or the casing.